Good afternoon students, welcome back to online bridge course maths class. So in the last class I have given properties of logarithms. So in today's class let us solve some problems on properties of the logarithms. So here the question is, find the value of log 5 to the base 10 plus 1 divided by log 50 to the base 10. So let us simplify this. So I will be writing log 5 to the base 10 plus 1 divided by log 50 to the base 10. So now this is equals to log 5 to the base 10 plus, here 1 can be written as log 10 to the base 10 divided by log 50 to the base 10. So in the last class I had given on property log a to the base a. Log a to the base a is 1. So here I am replacing 1 by log 10 to the base 10. Then in the next step this is equals to, now observe the numerator here, log x to the base a plus log y to the base a. That can be written as log of xy to the base a. Log xy, that means 5 into 10 divided by to the base 10 whole divided by log 50 to the base 10, log 50 to the base 10. Now in the next step log 5 into 10 it will be 50, log 50 to the base 10 then whole divided by log 50 to the base 10. So these two get cancels, the answer is 1. The answer is 1. So this is all about the question number 1. Note down this and then we'll move on to question number 2. Well, the question number 2, it is prove that log a the whole square minus log b the whole square, which is equals to log ab into log a by b. Let us prove the given question. So we know that a square minus b square, this is equals to a plus b into the bracket a minus b, a plus b into a minus b. Now I will take the left hand side. Observe the left hand side of the given question. It is in the form of a square minus b square. So now log a the whole square minus log b the whole square, which is equals to log a plus log b, log a plus log b, then into a minus b. A minus b is nothing but log a minus log b. So it is log a minus log b, log a minus log b. This is equals to, now in the previous class we have given the property log x to the base a plus log y to the base a can be written as log xy to the base a. So log x plus log y can be written as log xy. Similarly, log a plus log b can be written as log ab. So this is log ab. Then see the second term now, log a minus log b. So similarly, log x minus log y can be written as log of x by y. It can be written as log of x by y. So log a minus log b can be written as log a by b. Log a by b. So this is all about the question number 2. Note down this and then we'll take up the question number 3. Well, question number 3, it is solve log into the bracket 3 plus 2 times log 1 plus x, which is equals to 0. Solve means we will have to find the value of x. So write the given question now. Log into the bracket 3 plus 2 times log 1 plus x, which is equals to 0. So now in the next step log 3 plus 2 times log 1 plus x, which is equals to, so 0 can be written as log 1. So it can be written as log 1. So in the previous class, we have given the result. Log 1 value, it is 0. So I have replaced 0 by log 1. So both the sides we have to drop the log now. Cancel out log and write the remaining term. So what do we get? This implies 3 plus 2 times log 1 plus x, which is equals to 1. Now in the next step, take 3 to the right hand side, it becomes minus 3. 2 log 1 plus x, which is equals to 1 minus 3. So now 2 times log 1 plus x, this is equals to minus 2. So 2 get cancels now. 2 get cancels. Write the remaining term log 1 plus x, this is equals to minus 1. This is equals to minus 1. So this is there in the logarithmic form. So how do you write this in the exponential form? There will be base 10 here. So I had told you clearly in the previous class, if the base is not mentioned, we have to take the base as 10. So the logarithmic form is, if log x to the base a is equals to m, this is there in the logarithmic form, the corresponding or the equivalent exponential form will be x is equals to a power m. This is there in the exponential form, this is there in the logarithmic form. Now we have to write this logarithmic form in the form of exponential. So what do we get here? 1 plus x. So this remains as it is, 1 plus x to the, here which is equals to 10 to the power minus 1. This is equals to 10 raised to minus 1. So I have written the logarithmic form into exponential form. So now 1 plus x, 10 raised to minus 1 is nothing but 1 by 10 raised to plus 1. So now take 1 to the right hand side. X is equals to 1 by 10 minus 1. X is equals to 1 by 10 minus 1. This is equals to, this implies x is equals to, take up the LCM now, 1 minus 10 divided by 10, x which is equals to minus 9 divided by 10. So this is the required value of x. Note down this and then we'll move on to question number 4. Well, the question number 4, it is solve log 7x plus 3 to the base 3, which is equals to log 5x plus 9 to the base 3. So we will have to find the value of x here. Log 7x plus 3, this is to the base 3, this is equals to log 5x plus 9 to the base 3. So both the sides you have the same base, that is 3. So we can cancel out log or dropping the logarithm, write the remaining terms. So we are dropping the logarithm, we are left out with 7x plus 3, this is equals to 5x plus 9. So now I'll take 5x to the left hand side. What do we have? 7x minus 5x, this is equals to 9 minus 3. This is equals to 9 minus 3. So 7x minus 5x will be 2x, which is equals to 6. Then x will be 6 by 2. In the next step, we get x is equals to 3. So this is the required value of x for the given question. So note down this and then we'll take up the question number 5. Well, question number 5, it is solve log x minus 2 to the base 7 plus log x plus 3 to the base 7, which is equals to log 14 to the base 7. Again, we have to find the value of x here. So let us take up the given equation. Log x minus 2 to the base 7 plus log x plus 3 to the base 7, which is equals to log 14 to the base 7. So now observe the LHS here. It is in the form of log x to the base a plus log y to the base a. That can be written as log xy to the base a. These two will be multiplied now. So this implies log x minus 2 into x plus 3 to the base 7, this is equals to log 14 to the base 7. So observe the LHS and the RHS, you have the same base. That means we can cancel out log, or dropping logarithm both the sides, we get x minus 2 into x plus 3. This is equals to 14. Now simplify this. This is going to be a quadratic equation now. X into x, it will be x square, and then x into 3, it will be 3x, and minus 2 into x will be minus 2x. 3x minus 2x will be x. Then you get minus 6. This is equals to 14. Now take 14 to the left hand side. X square plus x, then minus 20, which is equals to 0. This is going to be a quadratic equation now. Multiply the first and last term. The product is going to be minus 20 x square here. So minus 20 x square is the product. How do you consider the factors now? After adding, we should have the middle term. So 5x minus 4x. These are the factors now. 5x minus 4x. If we multiply these two, we get the product minus 20x square. If we add these two, we get the middle term. So it can be written as x square plus 5x minus 4x, and then minus 20. This is equals to 0. So in the first two terms and in the next two terms, we will have to take common. So here x is common, we get x plus 5. Then here minus 4 is common, we get x minus x plus 5, which is equals to 0. Again in these two we have x plus 5 as a common term. X plus 5 into x minus 4, which is equals to 0. So now from this we get x equal to minus 5, and another one is x equal to 4. So here x cannot be negative. That is why we have to take x equal to 4 as the solution. This is all about question number 5. Number 6, it is solve log x to the base 4 plus log x minus 12 to the base 4, which is equals to 3. So we will have to find the value of x here. Write the given question. Log x to the base 4 plus log x minus 12 to the base 4, which is equals to 3. Now observe the LHS here. It is in the form of log x to the base a plus log y to the base a. In that case we can write that as log xy to the base a. These two will be multiplied now. Log x into x minus 12 to the base 4, which is equals to 3. Now this is there in the logarithmic form. This can be written into exponential form. So this implies x into x minus 12, this is equals to 4 cube. This is equals to 4 cube. So these two are equivalent. This is logarithmic form and this is exponential form. So now multiply these two. We get x square minus 12x. This is equals to 64. 4 cube. It is 64. Now take this to the left hand side. X square minus 12x minus 64, which is equals to 0. It is a quadratic equation now. Multiply the first and last term. The product is going to be minus 64x square. Now how do you take the factors now? So here after adding, we should get the middle term as minus 12x. So I will be taking minus 16x plus 4x. Minus 16x plus 4x. Multiply these two, we get the product as minus 64x square. Add these two, we get the middle term. So x square minus 16x and then plus 4x minus 64, which is equals to 0. Let us go for taking the common term now. In the first two terms we have x common, we get x minus 16 plus, in the next two terms we have 4 common. Take 4 common, we get x minus 16. This is equals to 0. Again in these two terms we have x minus 16 common and we have x plus 4. This is equals to 0. So from these two we get the values of x as x equal to 16 and another value is x equal to minus 4. So here x cannot be negative. X cannot be negative. That is why we should not consider x equal to minus 4. So x equal to 16 is the only solution for the given equation. So this is all about question number 6.